Equations with radicals. Remember, solving is where you're working backwards. You're trying to undo things so that you can find what the variable is actually equal to. Okay? So most of this is going to be really, really easy. The thing that's weird about solving equations with these things is sometimes you get what's called an extraneous solution. Okay? And an extraneous solution is a solution that does not make the original equation true. Sure. They're in the front of that bin where it says Algebra 1B. They should be in the very back of that big stack. Chapter 8 should be, yeah, that's it. Okay, a solution that does not make the original equation true. So the problem with these, and this is going to freak you out a little bit, is you can do the entire equation correctly. Okay, you can do every step you're supposed to do. But because of some of those issues that we've already talked about, the issues with the negatives, the issues with, you know, sometimes you can take a square root and get more than one answer, things like that, because of all of those problems, sometimes when you plug that answer in, and you've done everything correctly up until that point, okay, it's not that you made a mistake, when you get that answer and plug it back into your original equation, it does not actually make your equation true. And so what that means is that you have to check your answers to these equations. I know when we've solved equations before, I've sort of said like, hey, you should check your answers. With these, you have to, because it's possible that even if you did everything correctly, your answer does not make the original equation true, and then you have to say no solution, or that your solution is extraneous. Okay? You'll see what I mean. I hope I put one of those in here. I don't remember. So I want you to think back, and you don't have to write this down, but when we did equations like this, x squared equals 16, what did we do to get rid of the square? Square root, right? Because square and square root are opposites of one another. Okay? So what if you wanted to get rid of a square root? What do you think you could do? Not quite. Good think. Well, I guess kinda. When we had x squared, we used a square root to get rid of it. What if I had the square root of something? What if I had the square root of x equals, I don't know, 10? How would I get rid of a square root? Square it, yeah. I could square both sides, and the square root would cancel each other out just like they did over here. Okay? How do you think I would get rid of a cube root then? Cube it, a fourth root? Fourth it. Raise it to the fourth power. Okay? So that's how these work, is to get rid of a radical, you're just going to raise to that power. Okay? Because a power and a root are opposites of one another. So in this first one, the cube root of x equals 5. To get rid of that cube root, I'm going to raise to the power of 3. And then I'm going to raise this to the power of 3. Okay, those are going to cancel out, so I'm left with just x. And then 5 to the power of 3 is 125. Okay, so I end up with x equals 125. Easy, right? Okay, now we have to go back and check. So in your calculator, we need to type in the cube root of 125. Okay, I'm putting this 125 back in here for x. Do you remember how to do the cube root on your calculator? Yep. I would hit the number 3, and then if you're on a graphing calculator, you'll have to go to the math menu, and it's option number 5. You're looking for the little button that looks like a square root with an x over it. Okay? What'd you get, Emily? For the cube root of 125? maybe you typed in here. Yeah. Oh, so sorry. Yep, you did 3 times the square root of 125. You want 3, and then you want to use that one that has the x with it. Is it different? Oh. Okay. So you need that 3 kind of floating up over the radical. Did you get 5 as an answer? Yeah. And that's what we were supposed to get, right? So we're good. So that checks. This is our correct answer. X does equal 125. Okay, take a look at number 2. 12 plus the 5th root of t. Well, what do you need to get rid of before you start raising to the power of 5? Isaac?
12.
Yeah, let's get rid of the 12. So let's subtract 12 and subtract 12. Okay. So the 5th root of t is equal to negative 3. Okay. And then how do I get rid of that 5th root? How do I get rid of a 5th root? Raise to the power of, what power? 5. And of course, when you do this negative 3 to the 5th power, you're going to remember to put that negative 3 in parentheses, right? Of course. Actually, I don't remember what that is. 3 to the 5th power. Okay, thank you. Negative 243. So now in our calculator, we need to type in 12 plus the 5th root of negative 243. Okay. You may need to put this negative 243 in parentheses underneath that 5th root, depending on your calculator. Not sure if that's going to cause a problem or not. What'd you get? You got 9? That's what we were supposed to get. Okay. So it does indeed equal 9. So that means this is a correct answer. I hope I put one in here that was extraneous. Number 3. First of all, what kind of root is number 3? Doesn't have a number there. There's no number here, so that's a square root. Okay? But first I need to get rid of that 2 that's floating around outside. How do I get rid of that 2? Nope. Divide. That's 2 times the square root. So let's divide by 2. Divide by 2. I end up with the square root of g minus 5 equals 5. How do I get rid of a square root? What power do I raise to? Power of 2. Power of 2. So now I end up with g minus 5 equals 25. Now notice I'm not done yet. Okay, hi Alicia. Okay, whoops. Okay. G minus 5 equals 25. I'm not done. What do I still need to do? Okay, add the 5 to both sides. Yep. So G equals 30. Now to check that, here's how I would type it into your calculator. I would type 2 and then just the regular square root button, not the x root, in parentheses, because I'm putting, anytime you're putting more than one thing underneath a radical, I would put it in parentheses. So I would put 30 minus 5. 2 times the square root of 30 minus 5. And we want to see if that equals 10. Does it? Okay. Okay, so that one works too. Maybe I'll pluck one off your homework to do with you that comes out to be extraneous, just so you can see it. Questions on those so far? You feel okay on that? Are there more in the back? I don't remember. Oh, yeah. There are. Oh, yes, we are. Because I hope we can find one that's extraneous. Plus, we definitely need to see number 6. So. No, you'll be fine. There's some other stuff in these other ones that I want you to see too. Okay, so number 4. What do you want to get rid of first in number 4? Okay, let's get rid of the 6. So I would divide by 6, and I get the 4th root of m squared is equal to 2. Okay. What do you want to get rid of now? The what? The 2? I wouldn't get rid of that yet because that's underneath the radical. I can't really get to that until I get rid of that radical. How do I get rid of the radical? Raise to the 4th power. Good. Let's raise to the 4th power. Raise to the 4th power. So I end up with m squared equals 2 to the 4th power is 16. Now my problem here is that what do I have to do now? Now I need to take a square root of this. Square root, square root. And do you remember when we solve equations with square roots, how many answers do I get? 2. So here I would get m equals 4 or m equals negative 4, which means I'm going to have to check both. Okay? What worries me about these equations is not so much that you're going to have a hard time with solving them, but that if you're not careful about how you type it into your calculator to check it, you might think your own answer is wrong. So, here's how I would type this one in. I would type in 6 times, and then hit the 4, and then the x root of, okay, because that's going to be the 4th root of 4 squared in parentheses. Okay. Whoops. Go ahead and type that in. Let's see how that comes out. What do you get for that one? Do you get 12? Okay. So that one works, right? We need to check our other solution, though. We need to check our negative 4. And parentheses are going to be even more important here. I'm going to type it in almost exactly the same way. 6 times 4 times the x root of. Now what you have to be careful with here is when you take that negative 4 and square it, the negative 4 will need to be in parentheses. Okay? Let's type it in like that. Do you also get 12? Okay. So that one works with both solutions. Okay? So 2 answers to that one. Okay, let's look at number 5. What do you want to get rid of first in number 5? The 3. How am I going to get rid of that 3? Not quite. That's not 3 times anything, so I wouldn't want to divide. Okay, why are you saying add? Okay, except the 3 itself is positive, right? Okay, it's 3 minus something else, but to get rid of that 3, it's a positive 3, so I'm going to subtract the 3. And just leave the negative sign where it's at. So now I have the negative 4th root of y equals 7. Okay. So now how do I get rid of that negative? Not quite. Think of that as like a negative 1. If that were a negative 1 floating out there, how would I get rid of it? I would divide. Divide by that negative 1. Divide by the negative 1. So now I have the 4th root of y is equal to negative 7. And now to get rid of that 4th root, let's raise to the 4th power. So we need negative 7 to the 4th power. Please make sure to put that negative 7 in parentheses. So let's hear what you got. Okay, positive? Okay, yep, it should be positive. So y equals 2,401. And so to plug this in, I would type 3 minus 4 and then the x root button of 2401. And we want to know if it comes out to equal 10. What's that, Stephen? What'd you get? Negative 3?
4.
Negative 4? Negative 4? Okay, is that what we wanted it to equal? Okay, this is one that gets weird because of that negative sign in there. All right? So our answer did not actually make our equation true. We did everything correctly here. Mathematically, we did everything right. But this one does not work. Okay? So our final answer here, instead of being this, would be no solution. And then I would just maybe make a note next to it that you got an extraneous solution. That's what an extraneous solution looks like. You did everything correctly. They do tend to happen in the ones that have sort of some weird negative things going on. Okay? So that one is an extraneous solution. That means there's no number that would work there. Okay? And let's look at number 6. Number 6 is weird because it has 2 radicals in it. Okay? But here's how I want you to look at this. Over here you have 1/6 root of g. Over here you have 4/6 roots of g. If you had an equation that said just 1g plus 9 equals 4g, what would you do with the g's? Okay, you would combine them by subtracting the 1 from the other side, right? You would subtract 1g from 4g. I'm going to do that exact same thing here. Okay? I'm going to subtract 1/6 root of g from each side. So this is gone. And so here, if I have 4/6 roots of g and I subtract 1/6 root of g, what am I left with? 3/6 roots of g. Yep. Where do you want to go from here? Isaac? Good. Divide by 3. So I end up with 3 equals the 6th root of g. Then let's raise to the power of 6. Raise to the power of 6. 729 maybe? Am I right? Okay. So 3 to the 6 is 729. And that equals g. And now to check our answer, because you've got variables on both sides of your original equation, I would do them sort of separately. So first I'm going to do the 6th root of 729 plus 9 on the outside of that radical. So make sure you're not typing that plus 9 underneath the radical. Okay? Can someone do that and tell me what you get as an answer? 12. And now let's do the other side. So let's do the 4 times the 6th root of 729. And see if we also get 12. Yep. Okay, so because the 2 came out to be equal to each other, this one works. This one's good. So 729 is our answer. Okay. That's what we're doing today. Think you can handle that? Okay. Just equation solving, and the opposite of a root is that power. Okay. Just make sure you check